We see mountains, valleys, hills, and holes. And the seafloor is just as diverse a landscape. But did you know that in certain places on the seafloor, like in the Gulf of Mexico, there are even underwater lakes and rivers? How is that possible? Well, these lakes and rivers form when seawater seeps up through thick layers of salt, which are present beneath the seafloor. As the water seeps up, it dissolves the salt layer, causing it to collapse and form depressions. The dissolved salt makes the water denser. And because it is denser than the water around it, it will settle into the depressions, forming a river or lake. These underwater lakes and rivers can be as small as a few feet across or as large as a few miles long. They're even very similar to lakes and rivers on land, with shorelines, surfaces, even waves. And there are even some creatures that enjoy hanging out by these lakes, like underwater beach bums. Huge fields of mussels are found growing along the edges of some of these lakes, but they're not exactly sunning themselves. This far beneath the ocean's surface, sunlight is extremely hard to come by. As we know, sunlight plays an extremely important part in the food chain here on land. But this far down, organisms like these mussels have adaptations that allow them to get their nutrients from bacteria that can convert methane and other chemicals in the salty water into energy. While we've come a long way in our understanding of the ocean, most places are still unexplored, and many questions are unanswered.
Greatest surprises for me in filming Blue Planet, I think, were the cold seeps. I grew up on the Gulf of Mexico, and so I was pretty familiar with the Gulf, but I had no earthly idea what lived on the bottom of the Gulf of Mexico until Blue Planet. And we had the Johnson ceiling, these beautiful acrylic, 7-foot diameter acrylic balls that we were diving in, down to, as I recall, it was about 2,200 feet. And I'll tell you what happened was, we were going along, it looked like a lunar moonscape, just mud, nothing, a few little odds and ends, maybe a holothurian, sea cucumber over here, and sea urchin goes by, but not much. And then it started picking up a little more, and we must be getting near something. And suddenly, we arrived at this, it was just giant mounds of worms, these beautiful tube worms, just forests of them. But it's just beautiful and just springs out of nothing. Just a flat, muddy bottom, and suddenly, boom, it explodes with light around these cold seeps. That's not the most amazing part of it. For me, associated with the cold seeps, the most amazing thing, and actually one of the most incredible things that I've ever seen underwater anywhere, was when I went to the Gulf of Mexico for Blue Planet and filmed an underwater lake. And it's like, wait a minute, I'm already underwater. How can there be a lake? But it was. It was super saline water that had pooled into this giant lake. And it had a shoreline of mussels. Fantastic area. Fantastic area. I have no idea what's in the lake, but along the shoreline it's lush. This rich bed of mussels supporting brittle stars and all sorts of fish and a whole community of animals living. And then on the other side of the mussels, nothing. Mud. It's fantastic.
Over half a mile down, at the bottom of the Gulf of Mexico, they came across what appeared to be an underwater lake, over 20 meters long, with its own sandy shore. Around its edge, there even seemed to be a tide line. But this couldn't be, of course. This was underwater. In fact, the lapping edge was created by a thick soup of salty brine, far heavier than the surrounding seawater, and the sand was made up of hundreds of thousands of mussels. Once again, in the midst of a totally barren seabed, an extraordinarily rich oasis of life, totally independent of the sun's energy. The source of energy this time was not sulfides, but methane bubbling out of the seabed. And once again, the mussels carried special bacteria capable of fixing the methane's energy. Just like the hot vents, a complete ecosystem had developed based on the bacteria. There was an enormous variety of completely new species: shrimps, weird squat lobsters, and bright red polychaete worms. These oases were called cold seeps and were surprisingly similar to the hot vents. The geological processes in the sea floor that produce methane also tend to result in the release of hydrogen sulfides. It was hardly surprising then when, not far from the brine pool, they found tube worms.